Okay, the first question is find the limit of f of x as x is approaching 1 from the left. So as it's approaching 1 from the left, it's going down to negative infinity. So for question 1, the answer should be negative infinity. For question 2, it's asking how it's approaching 1 from the right. As it's approaching 1 from the right, we can see that it's going up to positive infinity. Number 3 is what's the limit as it's approaching 1? Since from the left it's going down and from the right it's going up and they're not equal, we're going to say it does not exist. For number 4, what's the limit as it's approaching negative 3? At negative 3 it has a hole, but as it's approaching the hole from the left and from the right, it's both the value of 1. For number 5, as it's approaching 3. As it's approaching 3, it has a clear value at negative 1, and both from the left and the right, it's approaching negative 1. For number 6, what is the limit as it's approaching negative infinity? As it's approaching negative infinity, we're going up to positive infinity. And for the last question for number 1, what is the limit as it's approaching positive infinity? As it's approaching positive infinity, it's going to run along this horizontal tangent at negative 2. Okay, I'm going to skip to question 9, where it's asking you if f of x equals the square root of 3x plus 1. They want to know what f prime is using your limit definition. So we know the limit as h approaches 0 of f of x plus h, which is the square root of 3 of x plus h plus 1, minus f of x, which is just the square root of 3x plus 1 all over h. Now when we do this, we have to multiply the numerator and the denominator by its conjugate. So we're going to multiply this by the square root of 3x plus 3h plus 1 plus the square root of 3x plus 1. Numerator and denominator, so square root of 3x plus 3h plus 1 plus the square root of 3x plus 1. On the notes in the PDF online this is a little bit clearer. So what happens when we multiply the numerators, we get 3x plus 3h plus 1 minus 3x plus 1 all over the denominator, which should be h times the square root of 3x plus 3h plus 1 plus the square root of 3x plus 1. And again, this is as the limit of h is approaching 0. So what happens here is this 3x cancels with this one. This positive 1 will cancel with this one. This h and this h will cancel. So this 3 stays on top. Now the limit as h goes to 0, this h should go to 0. So what we're left with is f prime of x is equal to 3 divided by 2 square root of 3x plus 1. And that is your derivative. You can check these by doing chain rule. Okay, I'm going to skip to number 12. And we're looking for the derivative of an ln. Now you have to remember, anytime we have the derivative of an ln, the derivative is 1 over its value. But this is chain rule because the sine of x is inside of it. So the derivative is going to be 1 over the u, which is sine of x, times u prime. U prime is cosine of x. So what we're left with is cosine of x over sine of x. Okay, I'm going to skip to number 14 now. You have a quotient. Remember, the quotient rule is low d high minus high d low over low squared. and you have an e to the 2x. E to the 2x, remember that's e to the u prime, that derivative. So when we're looking at f prime of x, we're looking at x squared times e to the 2x times 2, the derivative of the u, minus the high, which is e to the 2x, derivative of low is 2x, all over the low squared, which is x squared. Now, since we didn't say simplify, you're more than welcome to leave your answer exactly the way it is. Okay, so for number 15, what we have to remember that this is the root and this is the power. So when we write this, we're going to left with x squared plus 5x, and it's power over root, so it's the 3/4 power. So when we want to take a derivative of that, exponent comes in front. We're going to use chain rule. And take the derivative of the inside. Okay? When we're taking the derivative of a product, remember that we're going to use product rule, which we're going to assign u and v. So it's u v prime plus u prime v. So f prime of x will equal to the square root of x. Derivative of tan is secant squared. Okay. Okay, on question 20, we're looking at we want the tangent line of y equals 3x squared minus 2x plus 1. At the point x equals 1, we know when we plug in 1, you have 3 minus 2 plus 1. That gives us the point 1, 2. So that's going to be our x and y. We're going to take that derivative. It's 6x minus 2. We want to take that at 1 to get our slope. So we have 6 minus 2 is equal to 4. So therefore we have, oh, sorry, hold on, this is at negative 1. That's going to change this point. So negative 1 is going to be 3, plus 2 is 5, plus 1 is 6. So negative 1 is 6 should be our point. So at negative 1, that's going to make this negative 8. That should be our slope. So therefore we have y minus 6 equals negative 8 times x plus 1.